Ready? Okay, so what's the first thing that you did? Okay, hold on. Are you saying you're on this? You're talking about this problem right here, right? Okay, so it sounds like you got. Tell me this is right. You got. Well, there isn't anything you can do with 21 actually. Okay, so 21 times what? Okay, what does that give you? Okay, 315. Now this other part is the part that I don't think you knew how to do. What do you do next? Okay, so then you gotta multiply v to the fifth times v to the fifth. Because when you multiply powers, when you multiply, okay, so like, all right, so like, let's say this number here is 3, and this is 2 times 3 to the fifth. This number right here, this 3, do you know what it's called? It's called the base. And this number up here, do you know what it's called? No. Well, yes, exponents. But some people call it the power, but it's exponent, right? You with me? All right. So if you're multiplying with exponents, the bases have to be the same. This is super important. What did I just say? No. If you're multiplying with powers, with exponents, the bases have to be the same. What did I say? Okay. Am I allowed to multiply these two together? Are the bases the same? Then I can multiply them together. So when you're multiplying these together, you write down the base. Look, I don't do 3 times 3 at all. I just leave it as 3. And up here, this is super important. Whatever you're doing is not more important than this. You add these powers. You don't multiply them. Okay? This applies to like not just this problem, like a bunch of problems. So what is 2 plus 5? 3 7. So let's do this. So if I did 2 to the ninth times 3 to the fourth, what do I get? Wrong. Look away from that. All right. All my base is the same. Then you can't do it. Okay, ready? So you should have said Steve. Can't do it. Bases aren't the same. You're trying to trick me. Then I would have been guilty. So what if I did 2 to the eighth times 10,000 to the third? Can't do it. What if I do 2 to the eighth times 2 to the 10th to the 18? What if I do v to the fifth times v to the fifth, v to the 10th? You ready? All right, so we're multiplying these exponents up here. What do we get? v10. And then, so then there's only one more thing you have to do. Yeah, break down 315. So what goes into 315 for sure? Okay, 5 and 63. And then what do we do with the 63? Okay, 7 and 9. And chop the 9, right? Okay. And then what do you get? Perfect. And then, so then the final answer would be 3 root 35. Oh, actually, it's not the final answer. V to the 10th. Okay. Now you got to take the v to the 10th out. So remember, we did this yesterday. It's like you write down 10 of those. So v to the 10th. V to 10, V to 10, V to 10. 10 times, right? V10. I'm running out of room. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. Circle your pairs. One comes out. Boom, 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 boom. So how many V's come out? Oh, I didn't do that. 5. So tell me what's the final answer? Root 35. Perfect. Get it? Wait, so there's actually a really important lesson here. It's dealing with the exponents and bases. What's the lesson? Yes. And do you multiply the bases together? No. Keep the base the same and then you add the top. Okay. Keep going. Okay, so what do you do if you have like 5 squared times 5 to the third? What's that answer going to be? So if you have 5 squared times 5 to the third, what's the answer going to be? The new way. Sure. So these guys right here are called bases. And these guys are over here. 5 to the 5th. Okay. So when you multiply bases, do they have to be the same? The way you do the powers. Okay. If you take a power, like the power 3, to a power, don't you dare look at that text message. If you take a power to a power, what did I say? You multiply. So what's this answer? 5, 6. All right, so tell me the difference between the two situations here. I know that, but in the way you solve these problems. Yeah, if you have a power to a power, do you multiply or add? And if you are multiplying bases that have powers, same bases, do you add the powers? All right. Now look here. If you have a square root, like square root of 3, and you square it, that's going to be what? It's going to be the square root of 3 times the square root of 3, which is the square root of 9, which is what? 3. So if you take in a root, it's super important. Watch, watch, watch. This is one of those moments that you do not want to miss. You ready? You take the square root of 3 and you square it, you can just think of it as the hat comes off. What did I just say? Yes. So here's the hat right here. If you have a hat and you take it to a power, the hat comes off. So the square root of 3 squared is 3. Look, what's the square root of 200? I don't want to use 200. 300 squared. 300. Because the square root of 300 times the square root of 300 is the square root of 900. And the square root of 900 is 300. Okay? So look right here. You have the square root. Oh, I'm not doing your problem. Remember, I'm not doing your problem. So do not type in my answer. So 9m to the third v to the invisible 1. But yours does not put that 1 there. I'm putting it there for you. Then I'm going to go like this, and I'm going to square it like that. Okay, cool. Guess what? You got a hat to a power. What happens? The hat comes off. Just take the hat off. It's like I just get my little eraser, and I go like this. Watch, 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 watch. I just take the hat off. I get 9m. No, the hat comes off. That's all you do. You leave it alone. The hat comes off. Here's your answer. The hat comes off. The hat comes off. Here's the hat. Now it's off. Where do you see a 2? Is this a 2? Is this a 2? Is this a 2? Where's the 2? Yes. Because the hat comes off. Keep going. Good job. You're welcome. That was a really energetic thank you.